Today we'll be looking at how to print something in the standard output. So far the programs that we have written in the last two videos, we have been using the debugger to see how data is moved from one place to another inside the registers. But today I'll be showing you how to print something or some string into the standard output where you can see it printing maybe a value on your terminal. So without delay, I will go ahead and create my assembly file. So nano, I will name it as usual main.s, so you can name it whatever you want. Over here we'll go ahead and declare our text section. So this is to tell assembly that to locate our source code inside this section. Then go ahead and define the global or the entry point of our program. Then we put the start label over here. So writing into the standard output, there are some certain registers that you have to use sequentially in order to tell the operating system or to tell the program what to do. And before doing that, today we'll introduce another section that we have not seen, and the section will be called the data section. So section.data. So data. So one may ask, what's the functionality, or what does this section expect us to write? So in short, this section called data is used to declare data or constants that do not change while the program is running. So in short, you can say that, maybe I can write a comment. So used to declare, initialize, or constants that do not change during program execution. So this is where you declare your constants that will be readily available in the whole program. So we'll go ahead and declare some memory or some variables here that we will initialize, because you'll see that you can declare initialized data, maybe a string with a default text. So I'll go ahead and maybe declare a variable called name, then followed by the bytes that you want the computer to give you. So db meaning we want 1 byte of memory. So there is db, there is dd, these are 4 bytes of memory, so on and so forth. But we'll be using the db, but we'll be seeing some other instructions or some code that if you want some more memory, we'll be seeing that concept in our later videos that I will cover. So name followed by the size of the memory, db meaning we want 1 byte. So the db means we want 1 byte of memory, which is 8 bits, followed by the data. So you can use single quotation or double quotation, it doesn't matter. And I will just write my name. I will write my name, so maybe Cowboy the programmer, like that. Then I will follow this here by getting the size of our string. So you can write, because you can use manual, or you can hard code the number of or the length of the string, because at our data on our text section, the program will require us to write the size of this string. So let us see what we can do. So we'll go ahead just and write our program. So now here we will have I will introduce just a basic overview of system calls in Linux. So in order to write to the standard output, Linux expects you to put some numbers which means something to the system in order for it to know what to do. And we'll be using the EAX, EBX, ECX, and EDX registers to do that. So let me write the code. You will understand if I write it. So we'll move to EAX the value 4. So the value 4 inside the Linux operating system means that we are telling this is the number that represent a system write. So if you want to see more of the system calls inside Linux, I will leave this link over here. So you can see 4 should be put in the EAX register here to tell the kernel or the Linux kernel we want to write something. So I will leave this, but we'll be covering it in more details. So let me go back. We are telling 4. So this is to tell the Linux operating system to perform a write instruction. Now then we'll move another value into the EBX register and we'll put 1. So this tells Linux what function to perform or where to direct that write. So 1 meaning we want on the screen, 0 meaning it will redirect to the keyboard. But we'll be seeing standard input, getting input from the user from the keyboard. If you want data from the keyboard, we use 0, and here we'll be use 3 because 3 is the system input. But now we'll be using 4 because we want to write something, and then 1. We are telling it to redirect something to the screen. Then we'll move into ECX the pointer or the pointer to the data that we want to print. So the ECX expects a pointer, a memory address where our data resides. So I'll go ahead and just write name, meaning this. Then we'll move to EDX the size or the length of the data which is being processed over here. So as here you can go and counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we can go ahead and just type 21. But you can see that it is a tedious task. To every time you are declaring a string, you have to count the characters one by one. So I will show you a shortcut that you can use to get the length. So I will name it nameLen, then followed by this directive EKU, so then followed by a $, a dash, then the name of the variable. So with this will give us the length of our data over here automatically. So instead of doing 21, we can just say name len. So after that, we have to return control to the operating system for it to perform these instructions. Then after that, we have to gracefully exit our program. And how we will do that, we'll be using move into the EAX. We'll move the value 1. So as you can see in the document, in the system call table, 1 is system exit when you put it in the EAX register. So this one over here, so we put 1 to tell the machine that we want to exit our program. Then we'll move EBX. So EBX now expects the return value, so 0 for a successful exit code. So anything that is not an non-zero or a negative means that our program has crashed. So this is an equivalent of return 0, like that. So, and as you can remember, the semicolon represent comments inside our program. Now, sorry for I've mistyped this, so it's move. Then we return again. So then we return again the control back to the kernel of the operating system ETH for it now to operate again our instructions. With that, this program will print something into our screen. So it's very simple. So if we can go ahead and just summarize, so this is the data section, which is used to declare data, initialize data, or just constants. So, and we have seen that you can declare, you start with the name of your variable, followed by now the bytes that you want, or the bits that you want. db meaning that's 1 byte, dd 4 bytes, so on, and dw is 4 bytes, dd it's 8 bytes, so on and so forth. And here, this is a magic trick that we can use to get the length of our string over here. So the name of the variable, followed by the EQU directive, a $sign, then a dash, then the thing that you want to get the size of. Then we come here where we in the text section, and we move some values. So we move to EX the value for, meaning system write. So this is a sys system write. So this is, you can say that it says that write to screen. So, and here we have the pointer to the data. Now here we have the length of data print. Then we move here, so this means that this is sys exit. This is the return 0, the code that we want, or the number to indicate that the program has finished successfully. Then this is an interrupt. So this is responsible for returning control back to the Linux kernel. So this is now a simple program for displaying something onto our screen. So we'll go ahead and just try to run this code, and these semicolons, or this starting of a semicolon, we have seen that these are comments. So you can go ahead and save and try running it. So we'll be using NASM. We define our format, so it's an ELF32, then followed by the name of the assembly, followed by the object file, so main.o. Then we have to link it, so LD, we emulate the ELF i386, followed by, now we want the object file, then our final output file, we'll call it again main. So it has compiled successfully. Then let us run this executable over here. So main, so you can see it has printed my name over here. So you may ask, I want to print this thing into a new line. So let us see how we can do that. So I'll go here, over here where we have defined our data. I will just put a comma and put the number 10. So 10, it is an ASCII code, meaning a new line. So this is the same as saying like that. So you can put 10 or 0x10, the hexadecimal value, but I will put the value 10 to indicate a new line. Save it, exit, try to compile it again, then let me try again, then run it afresh. So you can see it has printed our name to a new line. So those are the basics of, maybe you have seen some concepts about system calls, but we'll be exploring those individual system calls in later videos, and we have seen how we can print something inside our we can print something to the standard output using the assembly language. If this video has been helpful to you, just leave a like, a comment, or if you want me to clarify something, you can leave a comment. I will sure get back to you. So So thank you for your time and see you on the next one.